the plan for this week. So let me be clear on this thing. So again, today we are going to learn the chain rule, which is the one that we pushed it from last Wednesday to today. So once we're done with chain rule, we're gonna done with this chapter 4, derivatives. Okay. So the content that we are going to put for you on the holiday is going to be total differentials and application. This one gonna be a clip from last year. So if you are interested to dig into it more, well, please watch it and then ask me if you have any questions. But if you feel like if you want to go slowly first, you can keep doing what are you doing here: limits and continuity, partial derivative, higher order derivative, and the chain rule. Because as I told you on the first day that we met, the content that I put on the holiday will not be on the exam. So if you, some of you like to go slowly, step by step, so you can focus on the content that we learn in the live lecture. Okay. And then, so no class on Wednesday. So today gonna be only an hour that we're gonna meet this week. And then we're gonna meet next week, April 11, for double integrals. So we're gonna start integration next week, okay? All right, so that is the plan. So some of you also asked me about the solutions. So here is what I posted last night is hints for practice problem for differential equations. So I think it is better for you to do the practice problem and then, well, you can check the hints for practice problem here if you feel like you don't know how to get started on that question. So this is basically a guideline for you to start that question. So I wrote it last night, so hopefully it's worked for some of you who have no idea how to start the question. But if you feel like you still cannot do it, so please send me an email. We can make a schedule, so we can make an appointment and then I can help you on point when you have a problem. So if you feel like you want me to show the whole solution, the entire solution, keep that question and then ask me on the review week, because we also have the review week on the the last week here on May 2nd and May 4th here. So this week we're gonna go over all practice problems. So we're gonna keep doing the problem so everyone get ready for the final exam. So if you feel like you do the practice problem all the way and you feel like, oh, I'm not sure this is correct or not, so keep that question and then we're gonna discuss on the last week before the final exam. Because this is going to be the week that we do problems again and again, just to make sure everyone can do the final exam. Okay. But on the way we have the guideline here. So if you feel like you want to check the guideline first, so this is a scratch work from that I give it for you, so you can see the direction that you go is good or not, or something like that. Okay. And also on my YouTube channel, some of you ask about something, the practice problem solution. So if I have the clip from last year, that is the solution, I post it for you here. So you can click on it and you're gonna see all solutions for practice problem on the limit and continuity. And here they are all recorded lecture from our year, this year. So it's gonna be recorded lecture, and if it is this cover, it's going to be the solution for practice problem from last year, which you can watch it as well. Sounds good? So any question in general for the format of the class? Anyone have any question? So far, so good? All right, if you don't have any question, good. So be sure to download this handout, the chain rule, and then we're gonna go over the chain rule today. Let's go. All right, let me share screen from my iPad. Right, hold on. All right, let's talk about the chain rule. Well, this is the chain rule. This is the chain rule handout. What you see in the slide now, this is the chain rule that you learn in Calculus 1. So in Calculus 1, when you learn chain rule, let me give you a review first. When you learn in Cal 1, you could have something like y as a function of t, and then t as a function of x. So if you draw a picture, it's going to be y as a function of t. T is a function of x. And then, okay, maybe I'm going to swap this thing so it's matched with the equation here. Y is a function of x and x is a function of t here. So for example, you could have y equal to x squared plus 1, and you could have x equal to 3 cosine t, for example. This is going to be the case that you have y as a function of x and x as a function of t. Sometimes people are going to ask you to calculate dy by dt. Hey, give me dy by dt. So in Cal 1, we say that if you want y is here and t is here. So you can look at it as a chain, like this is a chain, right? And then in order to go from y to t, you can go it via x. So that means you can do dy by dt as dy by dx, which means you go this way, y to x, and then x to t. So it's gonna be, and then multiply the x by t. It is actually not a multiply, but we can treat it. Yeah, it is a multiply, but what I want to say is some of you can think of this thing as the x gonna cancel out here. It is not actually a cancellation. It is actually because this is just a notation that we developed to make it a lot easier. But you can view this thing as a fraction, but it is actually not a fraction. But you can just cheat and then look at it as a fraction, because look at it. If you cancel out, so you're gonna get dy by dt, and then you get this thing. So in Calculus 1, when we do this type of problem, you're gonna say that, hey, if I want that, I can do dy by dx here, which is going to be 2x, because I differentiate this thing, dy by dx, and then I can differentiate this thing as well. So that's gonna give me something good, which is differentiate 3 cosine t, you get 3 negative sine t. And that's going to be your answer. And then sometimes you're going to say, oh, if I need a function of t, so I can replace x by 3 cosine t. That would be the answer. Does it make sense? That is what you learn in Cal 1. This is called the chain rule. Well, in Cal 2, when you have more than one variable, so if you work with function of 2 variables, the suggestion is that draw a picture every time. You will not get lost if you draw a picture. We're going to keep the same concept. So every time when we see the chain from y to x, from x to t, like that, we're going to make something like this. And then the formula is going to be more complicated. Okay, so let's look at it. So first of all, so we're going to have the chain rule. Case number 1, this is the easiest case. So suppose that we have the function of 2 variables fxy here. And then that x is a function of t. This notation means x is a function of t. That function name is g. Okay, this is y as a function of t. The name of the function is h. Okay, so if you draw the picture now, you're going to have in your head that, okay, c is a function of x and y. Okay, the name of the function is f, but yeah, this c is a function of x and y. And then x is a function of t, and y is a function of t. So you're going to get a chain like that. And if someone asks you, hey, let's compute dc by dt. So what would you do? So c is here on the top level. C is here on the top level. Well, I love to call this thing on the top level. This thing I call the bottom level. So you can see that the top level you have c over there. And the bottom level, you have t at 2 different locations. This one, location 1, and this thing, location 2. In order to get from c to t, you can go by two ways. So the first one is you go via X. The second one, you go via Y, which means you can do, it's gonna be, it's gonna be first you go this route, C to X and X to T, right? So it's gonna be dC by dx times dx by dt. Oh, that's the green one. That's the green one. Okay. And then let's do the yellow one. So, and then you add it up. The yellow one is going to be dc by dy times dy by dt. So you can start from this thing first. Now let's fix the notation, because this thing, c is a function of x and y. Well, when you differentiate, it's going to be partial derivative, because this is a function of two variables. And then you can differentiate with respect to x or differentiate with respect to y. So we're going to fix this notation to be curl. So it's going to be partial derivative. But this thing, you don't have to fix anything, because x to t, this is just only a single variable. So dx by dt, you can keep it. But this thing, we're going to fix the notation a little bit. So it's going to be partial derivative here. Curl c by curl x, curl c by curl y. Make sense? The formula that you get here going to match with the one that it gives in the book. Oh, okay, hold on. This is the thing that I copied from the book. So if you look at the Stewart book, you're going to see this notation as well. So some of you are going to have a hard time to also have a hard time to see the difference between curl F and curl C. They are the same thing, everyone. So you can use C here, curl C or curl F on the top here. Doesn't matter, because C is a function of F. C is a function of x and y. The name of the function is f. So sometimes the book gonna say curl f. Well, curl c, the same thing, because c and f, they are the same thing. Does it make sense? F is just the name of the function. Yeah. So that's how you do the chain rule here. All right, so let's take a look at example, okay? So this is all the concept, but let's go to the example. All right. So example 1, so take a look. You have c as a function of x and y. See that? C is a function of x and y. You have x as a function of t. You have y as a function of t. So in your head, you should have something like c is a function of x and y. And then x is a function of t, y is a function of t. It's going to be case number 1. Super easy. And then the question can ask you to find dc by dt, which means the way you think, you have to think that c is on the top, t is on the bottom. Well, how many ways I can go from c to t? So it's going to be 2 ways. The first way is going to go via x. The second one is going to go via t. So when you give the formula from the chain rule, it's going to be, well, dc by dt on the left here, going to be curl c by curl x, because you go this route. And then x to t is going to be this one, multiply it, boom, you get the first one, and then add, well, the second chain here, going to be curl c by curl y, dy by dt. Does it make sense? Well, again, if you draw a picture, you will not get lost. And the chain rule going to be super easy if you draw a picture. Okay, you don't have to actually memorize this formula. If you draw a picture, you can develop the formula here from the picture. And this is what you should do. And this is how everyone do. Mathematicians, they do this way. So they never memorize this formula. So they're going to start from this. Because, sometimes if you see C is a function of another one, UV or something, and this is ST, like the chain can be more complicated. And you will not get lost if you draw the picture and then you start from the beginning. Okay, so let's look at how they do it here. So dc by the curl c by curl x here. Well, you can see c equal to this function, right? Well, what they do in the book here, they're trying to do the partial derivative with respect to x. Again, partial derivative with respect to x, keep y constant. So look at y as a constant. So x squared y here, y is a constant. So you see, they keep y. And then they differentiate x squared, so they get to x. Simple like that. And then 3x y to the 4th power, y to the 4th power is constant. So you see, they keep 3 y to the 4th power. differentiate 3x. Yeah, actually 3 is also constant. You keep 3 and then differentiate x, you get 1. You know, and dx by dt here, you're gonna get sine 2t here. So yeah, by the chain rule, it's gonna be cosine 2t, and then you have inner function, so you have 2. Well, that's nothing harder than differentiation from one dimension. This notation requires you to do the partial derivative here, which I believe that everyone can do it from last week. And then dc by dt here gonna force you to do just a single variable differentiation. Okay, and once you get this thing, so the problem asks you to plug in t equal to 0. So you plug in t equal to 0, t equal to 0 here, x and y here, you can compute it, because if you know that t equal to 0 here, you can plug in x and y. Make sense? Because if t equal to 0 here, so sine 2t gonna be 0 as well. So when t equal to 0, x gonna be 0 as well. And then when t equal to 0, y gonna be 1 here. So you plug in t equal to 0, x equal to 0, and y equal to 1. Bam, 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 bam here. And then you're gonna get 6 as your answer. Well, this is the very first example in the book, and I hope this is not too complicated for you. So I just copied the whole question here just to explain it for you. This type of question is easy. Well, we're gonna learn something harder. Okay. All right. Example 2. Let's take a look at the example that it match with something that you learn in chemistry, or some applications or something like that. Okay. Let's start by looking at the example 2. So the pressure P in kilopascals, volume V in lit, and temperature in kelvins. Well, this could be the PV equal to nRT, some gas equation in chemistry. So, but anyway, we're gonna reduce the form to just PV equal to 8.31 times T. So basically, you have this equation. This equation shows the relationship between pressure, volume, and temperature. Okay, so let's look at the question. The question said that find the rate at which the pressure is changing. Well, this thing means they want to find dP by dt. Okay. Well, the thing that I highlight here, the rate at which the pressure is changing. This one mean, oops, this, oh, what the heck? This one mean dP by dt. Okay. Well, when you read the question and they ask you the rate mean the differentiation. This is from just the the basic background from Cal 1. So basically they ask you to find dP by dt. Well, what you can do here now, you can see that okay, you can say P is a function of 3.81 T over V. You can do that because you can move V to another side. So this is P equal to that. Okay, and then let's look at what they give it in what you have in the question. So that when the temperature is 3000 kelvins and increasing at the rate 0.1 Kelvin per second, and the volume is 100 lit, increasing at the rate 0.2 lit per second. So basically they want to find dP by dt when the yellow highlighter here is given. So basically we want to find dP by dt when you know that the temperature and volume are going to change a little bit. So basically, well, let's summarize. So we need dP, we need to find dP by dt where t equal to 300, and then dt by dt, well, it's going to be capital T and small t. Small t is time, capital T is temperature, 0.1, right? And then you're going to have V, the volume, to be 100. And then the last one is the volume going to be increasing as the rate 0.2. Okay, this is the information you have. So it takes a few minutes for you to write it out. And then now you can see that the term that you need is dp by dt. Well, you have something like this now. P is a function of T and V, right? The pressure, well, from here in the box, the pressure is a function of temperature and volume. This equation tell you. And then actually the temperature depends on time too. And also V here, volume depends on time too, because it can be increasing, it can be decreasing when the time change. So which means this is going to be the function of T time too. So basically you can apply the chain rule now. So it's going to be, okay, dp by dt. Well, P is on the top here. So T is in the bottom level here. So you're going to need dp by, okay, dp by, okay. Well, I shouldn't use dp now because it's going to be partial derivative. So curl P by curl capital T. This is the different partial derivative of P. Partial derivative of P with respect to capital T. And then differentiate capital T to differentiate small t, okay? And then plus the curl P by curl V. And then dV by dt. Okay, basically what I did, just follow this one, the first line, and follow this one, the second line. And then you're trying to plug in everything. That's gonna be the answer, okay? So here, let's take a look. The first one, you have this thing in the box, okay? So if you want to differentiate P with respect to T, so 8.31 and V, they are constant. So you can move it out, which means you differentiate, you get 3.81 over V. Easy, right? Because T is only variable over there. And then d capital T over dt here, it is given to be 0.1. And then plus curl P by curl V. Oh, this is a little bit harder. Well, you need P here, differentiate with respect to V. So 3.81 T here, this is constant, so you can pull it out. And then differentiate 1 over V. So you get negative 1 over V squared. So basically you're gonna get here to be negative 8.31 times T over V squared. Okay, and then dV by dt at the end. So this is given to be 0.2. So the term that you could have some harder things to do gonna be this term, because you know 3.8.31 T is constant, so I pull it out, so I have it here, and then I differentiate 1 over V. If you are not comfortable to differentiate 1 over V quickly like me, you can say 1 over V equal to V to the negative 1. And then when you differentiate, you're gonna get negative 1 V to the negative 2, right? Which is negative 1 over V squared that I put it here. So, well, but you know, if you feel like, oh, I do differentiation so many times, I can differentiate 1 over V and then I get negative 1 over V squared. You can do it. Yeah, I believe it. You know, if you take time, you can do it. Yeah, it's like V to the negative 1 is easy one. And then now you can do dP by dt and then you evaluate, well, when T equal to 300 and V equal to 100. You plug in all the numbers, so you're gonna get the answer now. 8.31 over 100 times 0.1, and then plus, okay, use the minus here. 8.31 times 300 over 100 square, and then 0.2, and then when you hit the calculator, everything gonna be just the number you want, and the number you want here is negative 0.042. Well, I did it already in my handout, but you know, it's just a calculation by using a calculator. At the end, you can conclude that the pressure is decreasing at the rate negative 0.042. What is the unit? Pascal, kilopascal per second. Okay, so the pressure is decreasing at the rate 0.042 kilopascal per second. Well, that is one application that, you know, this is the example in the book as well. So you can see that this concept is based on the chain rule. Anytime or every time if you have a function of two variables and you can draw a chain, draw a diagram, it's going to be easy because you're going to make up your chain rule here. And then you try to find the information for each piece and then combine it together. And then that will be your solution for this type of question. Any questions so far? Anyone need more explanation at each step? Anyone have any questions? Example 2 here. So far, so good. All right, so I believe that you are listening to me. Okay, so next one. Well, let's take a look at more harder chain here. So you already know the basics, but now you can see that if the chain is bigger, do the same thing, everyone. So let's say that suppose you have, well, let's look at the chain here. If you have C, it's a function of X and Y, but on the second step, you also have X is a function of S and T. Y is a function of S and T, okay? Well, it's mean when you do D, let's say that if the question asks you to do DC by DS, well, I should say co-C by co-S now because C, at the same level, you have S and T here. So when you do when you do DC by DS, you have to say it is a partial derivative. Because at the same level with S, you have more than one variable. It is not just S, so it have S and T, which means when you do co-C by co-S here, so you can, well, again, if you feel like you still have a hard time to follow, so let's think this way. So C is on the top level. On the bottom level, you have S. Again, how many ways you can go from C to S? So the first one, you can go this, and then this. So it's going to reflect you here because you have co-C by co-X and then co-X by co-S, right? From C to, you can go with S first. That's the first way you can do. So that's going to be your first term here, come from using the first way here. The second one is going to be the purple one here. And then you can go to S from this way. But you have to pass through Y, which means it's going to be this term, the second term. So how many terms you need to get from C to S? If I have another one like U and then S, so I need to add one more. The chain can be more complicated, but well, this is the case number 2. So the formula here, no need to memorize. So if you know the diagram, everything gonna be easy. Sounds good. So this is the same concept as the second one here. If you want co-C by co-T here, there's gonna be 2 ways, this, and this, right? So the first one gonna be co-C by co-X and co-X by co-T, and co-C by co-Y by co-T here. You can see, well, some of you are gonna have a hard time to denote the difference between co and D. Well, if you feel like you have a hard time to do it, use co. But if you can see the difference, so if you have only one leg here, just only one line here, on the next level, like the straight line here, so you can use the D like this, the regular D. But if you have more than one, it's gonna be partial derivative, so you can use co. That is the correct one. But if you feel like you are super confusing about this thing, I would suggest you to use co all the way. So just sometimes if you have only single variable, in some books they use co as well. It's okay. Well, I'm not going to subtract your point if you use different notations, as long as you understand, but your notation is not correct, but you understand it. Yeah, well, we're gonna give you full credit anyway, because it's just only the way that you cannot see the distinction of the notation in that point. Okay, so let's look at the example 3 here. So let's try to do this example together. All right, so well, we have C equal to E to the X sine Y, and X is ST squared, Y is S squared T. All right, so the question asks you to find 2 things. So co-C by co-S and co-C by co-T. Well, again, every time when you do this type of question, draw a diagram. So it's going to be C is a function of X and Y. X is a function of S and T. Y is a function of S and T. So this is all you have. And then now you're going to need to find cos C by cos S, right? So, well, the first one, I'm going to go by the yellow line. The second one, I'm going to go by the green line. So that means going to be cos C by cos X, and then cos X by cos S. Wow, easy. And then cos C by cos Y, and then cos Y by cos S. Okay. And then cos C by cos X, the first one here. All right, so we need to differentiate C with respect to X. So Y going to be constant. So sine Y go out. And then differentiate e to the x, you get e to the x. Okay, give me the same thing. So the second one, cos x by cos s. What is cos x by cos s now? Differentiate x with respect to s, you get t squared. Okay, t squared is constant. And then plus cos c by cos y here. Well, you have to keep e to the x. This is constant, right? And then, well, if you cannot follow me, cos c by cos y here, we're going to keep e to the x because it is a constant, and then differentiate sine, you get cosine. And then cos y by cos s, so this is going to be 2st. Because you keep t, differentiate s squared, you get 2s. Okay, well, done. No need to simplify. You know, if you feel like you don't want to waste time to simplify, that's totally fine to me. So keep that answer, because if you simplify it and you get it wrong, you lose your point. So if on the exam you stop here, I'm happy. That's just full get it. Okay. And the next one is okay, you can do cos c by cos t too. Well, this is the easy example. C to x, x to t. Okay. So cos c to x, cos x to t, and then plus cos c by y, and then y by t. Okay. Well, when you do this type of question, you can copy the top one. You can see that cos c by cos x here. Copy that one. You already compute it on the top, sine y e to the x. And then you need just cos x by cos t, which now you have to differentiate x with respect to t. This time going to be 2st, right? Because here, differentiate with respect to t, you get s times 2t. And then plus e to the x cosine y. Copy that one. And cos y by cos t, you're going to get s squared. All right, done. Well, give me a thumbs up if you understand this thing. So this is the main content for today, the chain rule. Anyone have any questions so far? All right, it's pretty simple, nah? I think it's pretty simple. If you feel like, yeah, good, you understand, yeah, about 6 or 7 students understand it. All right, thank you. Thank you everyone who participated. All right, so, well, easy, right? So I hope that if you see harder chain or, you know, more complicated chain, you can do it. So here, this is in general. They say that, you know, in general, they say that if you have u is a function of x1 to the xn. So they say that if u is a function of x1, x2, x3, x4, dot, can be lot of x and then up to xn. And each xi here, you're going to have t1, t2, dot, up to tm. Well, each one you have t1, t2, dot, up to tm. So you can see the chain could be complicated, but well, the way you can do is if you want cos u by cos t1, let's say, you're gonna do the same thing. You find all the t1 that you have on this thing, and then you can do the chain, like start from the top level and trying to find every single way that you can go from the top to the bottom. And then you make a notation like that. Well, it looks complicated when you see in the box here, because who's gonna memorize that? You know, no need to memorize. You need to draw the diagram first. And once you have the diagram, you can just start from that diagram. You're gonna get this equation automatically from the diagram, okay? All right, so let's look at example 4. Let's take a look at the chain rule in general. So I will give you an example here because I don't like the example from the book. It is not that complicated in the book. So let's suppose that you have c equal to, let's say, x squared y times sine c. No, let's see, x, y, c is just complicated. U v squared times sine w. Okay. Now you have three variables. So it's going to be c times c, u, v, and w over there. And then you see u, let's say I have u equal to 2s plus s cosine t. That means u going to be a function of s and t. And then let's say I have v to be just t. For example, let's say I have t squared log t. So u or v going to be just t here. It could be the case that you have only a single variable over there. And then the last one, let's say you have w equal to 3 plus 2 sine st here, which means this is going to have s and t as well. You know, if you have the chain like this, well, more complicated. So that means you're going to have curl c. Let's say if I want curl c by curl s. So you can look at c here and you can look at s here. Well, you can see there are only two ways to go to s here, right? There's no way you can go to s via v because v is a function of t. So which means when you do it, you can do curl c by curl u and then curl u by curl s. This is going to represent the first line here. Okay, and the second one is you can do curl c by curl w and curl w by curl s. And then that will be your answer. So if you differentiate, and then you get this four term, you add, multiply and add them up. This is going to be the answer, okay? Well, I will not do the calculation here, but well, the purpose of this example, I want to show you how to set up the chain because this is so important. If you can do this, that's all the chain rule. That's all you need for the chain rule. And here are curl c by curl t. If I want that thing, it's gonna be curl c by curl u by curl. This thing gonna have t terms. This curl c by, you need v now. Well, for v here, you can use dv by dt if you want, because you can see this thing is like only a single variable now. That is why the notation you do not need to use curl. Now you can use dv by dt because it is just a single variable. And then here you can keep curl c by curl w and then curl w by curl t. Okay, simple. Well, if I have something like st and k square, for example, this could be k as well. Who cares about k, right? We do not care k, so just keep it there, right? So because we differentiate with respect to s and differentiate with respect to t. Sounds good? All right. Anyone have any questions on this? Well, hopefully you absorb the concept of the chain rule from today's class. This is from the beginning up to this slide, they are all easy. This is the easy example for the chain rule, and I hope everyone can do it. Well, we're gonna wrap up the class for today by looking at the last one. This is the hardest example. So when you do the chain rule, things can get complicated by doing the second order partial derivative. I'm gonna show you this question. This is the final exam question from last year, like the BBTECH last year. I put this one on the final exam, and I think about 70% did pretty well on this question, if I remember it right. So, well, let's practice how to do this when you have to differentiate 2 times. So things gonna be more complicated. Well, I give you more space here to do it 2 pages. When we are done here, we're done with this class today. So, well, take a deep breath because this example gonna require you a lot of energy to do it. Okay, let's go. So we have w equal to fxy here, which means you have w is a function of x and y, and then x is 2u plus 3v, so x gonna be u. and v here. And then y equal to uv, so y is uv. Okay, this here looks simple. However, so when you face okay the notation, they want us to derive this thing in the box and show that it is equal to that. All right, let's do it. So this notation that I highlight in light blue, it means you need to differentiate w with respect to u first. Is that right? To v first, sorry. Because this notation we read from right to left, which means you're gonna differentiate v with respect to v first. Okay, we're gonna do the first time. The first step, take the derivative with respect to v. So what happened here? W is here, v is here. Okay, let's go. Chain rule. So it's gonna be w via x, and then co x by co v, and then plus w with respect to y, co y by co v. Okay. Well, now if you can simplify any term, simplify first. So, well, co w by co x, you have to keep it there because you don't have any function that you can differentiate. Co x by co v, this is good enough to differentiate because you already know that x equal to 2u plus 3v. So differentiate x with respect to v, you get 3. Okay, and then plus this term cannot do anything, keep it there. And then the last term, co y by co v, okay, this one you can do it because it's uv here, differentiate with respect to v, you get u. Okay, all right, and then now this is the form of the first derivative. Now let's take a look at the other one. So now you want to differentiate one more time with respect to u. Okay, because you need a second order derivative. Does it make sense? Well, you need a second order derivative. That means you, 1 second. That means you need to differentiate one more time. Okay, so let me, how do I close this thing? Sorry, something just popped up on my laptop. That's why I was like, oh, I cannot see the screen. Okay, now, okay. Now it's come back now, good. All right, okay, next. All right, so now we're gonna differentiate the second time here. So that means we're gonna plug in that thing, okay? If you want to look at that, so w with respect to x times 3, and then plus w with respect to y times u, okay? Now, because you are doing the differentiate with respect to u, and this is plus, break it up, okay? So it's gonna be two terms, differentiate with respect to u of the first one, co w by co x times 3, and then plus differentiate with respect to u, co w by co y times u, okay? So we're gonna, well, to make it easier, we're gonna call this thing the first term. We're gonna call this thing the second term. If we compute the first term and the second term and they add them up, you get something back in the box over there, you're done. Okay, so let's do the first term, term number 1. So how do you adjust term number 1? So you're gonna get, okay, let's do the green pen here. So co u, differentiate with respect to u of this term. What would you get? So you can pull out number 3. Okay, because that is the constant. What do you have here? You have differentiate w with respect to x first inside the parentheses, and then the outside parentheses you differentiate with respect to u again. So you can see that the problem here is that similar, you have something inside here, like you can treat this thing as like the box inside here. You're trying to differentiate this thing with respect to u. The thing that you have in the box here, it depends on w. So basically this thing in the box here, this is on the top level. Okay, and you're trying to, well, co w by co x here is on the top level. You're trying to differentiate this thing with respect to u. So by the chain rule, you have to go this way and this way. So let's take a look at what I'm doing here and see if you understand it. So I'm gonna keep this thing as a green one, and then I'm gonna say, okay, it's gonna be 3 times well, I'm gonna keep the green one over there, and then I differentiate with respect to x first, and then x by u, and then plus differentiate with respect to y, and then curl y by curl u. All right, a bit complicated. Well, I'm gonna do the highlight, the green one here, so you can see it a lot better. So you can view this thing as a something. Well, if you wanna make another name, you can make another name, but that name, the red box, gonna be on the top level over there. Does it make sense? When you do wanna differentiate that red box with respect to you, you need to go the chain by via x and via y, which means you can do, hey, it's gonna be here via x, and then x by u, right? And then here, and then y by u. Does it make sense? Sounds good. Anyone have any question up to this point? Is it close the Zoom already? No. Okay, good. Okay, next. All right, so we're gonna copy this thing. All right, so copy that one. Okay, 1 second. Just copy this term then. All right. Oops. All right, so this is the term number 1. Okay. All right, and then here you're gonna get 3 times. All right, so the first term here, well, now you can prove it up because this is the same x now at the same level. So differentiate w with respect to x, and then you differentiate with respect to x another time. So this could be curl square w, so curl x square, good. And then times curl x by curl u. What is curl x by curl u? So we have x is 2u plus 3v, so that is 2. And then plus this is going to be curl square w, curl y by curl x, because this term, and then that's gonna be curl y by curl u. Y by u is gonna be v. Okay, y by u gonna be v. Okay, so looks like we have something good because we have 6 times curl square w by curl x square, and you have 3v curl square w by curl y by curl x, which means if you change the name w to f, which you can change w to f because at the first place you have w equal to fxy, so you can replace here by f. Basically, what you have here at the end from the first term, you have these 2 terms already. So you need to show that the second term gives you another 3 terms here, and that will be done for this question. Okay, sounds good. All right, I need to keep going because we're gonna run out of the time, but you know, we can come back next week to repeat this example again if you want. But well, let's look at the term number 2 here. Well, the term number 2 here, you have this term, okay. Well, let's take a look at that. So we're gonna copy that term. All right, this is the A level question, you know. If you can do it, you're gonna get like A or B plus for sure. 2 here, curl u by curl u, and then this thing. You can see now this time you have curl w by curl y, and you have u here, which you need the product rule, right? Because you have w x to y, and you x to uv and y to uv. So you want to differentiate the inside term with respect to u. The inside term, it depends on w, and you know you have u here as well, which means you're gonna need the product rule. So now you're gonna start from, let's take a look at the yellow one and the blue one here. So let's first apply the product rule. It's gonna be differentiate the first one, and then keep the second one, and then plus keep the second one, and differentiate the first one. All right, it's like u dv plus v du by the chain rule. And then here on the first term here, a bit complicated again, because inside you have something that depends on W, and on the outside you have differentiate with respect to U. You cannot group it up now because this is different level U and Y. They are on the same, they are on different level now. So this term gonna be harder for us. So we're gonna do the same thing. So we're gonna apply the chain rule by looking at the term inside here to be just look at the circle term, and then it's on the top level. When you want to differentiate with respect to U, you can go via Y and via X. So which means you're gonna do here differentiate with respect to X, and then co X by co U, and then plus differentiate with respect to Y, and then co Y by co U. So basically this term, it just from the first term, and then we apply the chain rule to that one, and then multiply U, and then co W by co Y here. Well, let's keep it there, and then differentiate U with respect to U, you get 1. Okay, so this term gonna be co square W now, co X co Y. Well, differentiate X with respect to U. What is differentiate X with respect to U? So you already compute it from last time, it's number 2. So, and then plus here, co W, co square W, and then co Y square, because this is differentiate with respect to Y 2 times. And then differentiate Y with respect to U, this is V. You already computed from last time. And then, okay, everything multiply U. And then plus co W by co Y. Okay. Well, now you simplify it. So hopefully it's get back to the thing you want. So it's going to be 2U times co square W by co X co Y. And then plus U times V co square W by co Y square. And then the last one is going to be co W by co Y square. Again, if you don't like W, you can change it to F, because they are just different names. So we're going to change it to F. So we get the final answer we want. Choke, and choke. Well, this thing going to be the last 3 terms here, which is good, right? You know, because you are going to have last T term here. The thing that I highlight in light blue here, we have it here. The first 2 terms, you're going to have it here. And that complete the proof. So we already showed that the thing that we want, you can derive it, and then you get the something in the box over there. All right, you see, a bit complicated, right? All right, and that is all about the chain rule that we learned today. So if you want to practice the content from today, so here, example 28, 29, 30, and 31, they are all simple, because they are 28, 29, 30, and 31. You can copy example 1, 2, 3, 4 from today. And you know, if you draw the chain, it's going to be easy to compute. Well, the challenge one going to be 32, because it's going to be similar to example 5. So again, when you do the differentiation 2 times, second order partial derivative, things going to get more spicy, more complicated. So you have to be careful a lot about what you're trying to differentiate here. Well, let's stop here. And if you feel like if you watch my recorded lecture and you feel like you still do not understand this thing, we can come back next Monday and explain this thing again if you do not understand. Okay, but you know, I hope that for the class today you understand at least up to this example, because from the first page up to this page, that should be easy. And the last example, this could be the challenge one for some of you who want to get better grade. Like if you don't want to stop yourself for B and B plus, you want an A, maybe you need to complete this type of question as well to get, you know, higher grade. Well, but you know, I'm happy to give you B or B plus if you can get up to this page, but A must be a little bit challenge, you know. Well, let's see if you can work on the chain rule here. So we have 2 minutes left. Wow, today I almost over the time. Any question, Kap? Any question, anyone? Sounds good. Well, if you don't have any question before you go, type your name in the chat and then sign out. So I know you are in today. Sorry, so I forgot you. I forgot to check you in today. But well, type your name in the chat and then you can go. Crap. Thank you. We'll see you next Monday, everyone. Thank you for attending.